This video is going to discuss graphing linear inequalities in two variables. So first of all, let's remember that a linear equation in two variables looks like the following: ax plus by equals c. Recall that this is actually a line. So what we're doing in this section is we're going to be talking about linear inequalities with two variables. So a linear inequality looks like this: ax plus by, but then instead of an equal sign, we have either a less than or equal to, greater than or equal to. So it looks just like the above, except we have an inequality sign instead of an equal sign. Okay, so what does this determine if the other is a line? So this actually determines a region in the plane. In other words, it's not a line, but it's some piece of the plane. So I'm going to go over a step-by-step approach for how we can actually graph these things, figure out what the region looks like. So these are the steps for graphing. So step one. The first thing you're going to do is you're going to put in slope-intercept form. So slope-intercept form, if you recall, was y equals mx plus b. This is going to be y, then one of the inequality signs, and then mx plus b. If slope-intercept form is foreign to you, you might want to go back and view one of the older videos on graphing linear equations, and where we talked about slope-intercept form. But you do need to understand that in order to do this section. So that's step one. Step two. What you do is you graph the boundary line. The boundary line of the region is what happens when you replace it with y equals mx plus b. So recall, you graph these things like you did before when you first learned how to graph linear equations. You have the slope, you have the y-intercept, and so you can just go ahead and draw your graph. One thing's a little different though. You're not going to always make this a solid line. If it's less than or greater than, you're going to use a dotted line. And if it's less than or equal to or greater than or equal to, you're going to use a solid line. Okay. So after you do this, step three, you're going to shade above or below the boundary line. Now, how do we decide whether it's above or below? Well, if it's less than or equal to, since you have y less than, that means it's below. So you're going to shade below the line. And if it's greater than or equal to, you're going to shade above the line. So those are the two cases you have to look at. Very important now for this step, so important that I'm going to write this down. For this last step, for step three, make sure you look at the inequality sign. From step one, when deciding shading. So when you're deciding which side to shade on, make sure that you look at the inequality sign in this step, not in this step. They might be different, believe it or not. Okay, so let's do a couple of examples to illustrate what we learned. So for all of these, we're going to graph the solution set. So number one, negative x plus y is less than or equal to 2. So step one, the very first thing we do is we put in slope-intercept form. So I'm going to add x to both sides. I end up with y is less than or equal to x plus 2. Y is less than or equal to x plus 2. Then what I do is I graph the boundary line. So remember, the boundary line is y equals x plus 2. So the slope here is 1, and the y-intercept is 0, 2. So let's go ahead and graph that. 0, 2 would be right here. Slope being 1 means I go to the up 1 and to the right 1. So it looks like this. Now, do I do a solid or a dotted line? Well, according to step 2, if it's less than or equal to, which that's what this problem is, I'm going to do a solid line. So the line looks like this. Finally, I'm going to shade above or below. I look at this symbol right here. Now, because that is a less than or equal to, I shade below. So it looks like this. In other words, that entire region is the solution here. We should probably label a few points just to make sure that we understand where this boundary line is. And that is it. We're done with the problem. So this isn't much harder than graphing. It's just that one extra step of whether it's solid or dotted and which way we shade. Let's try another one. Negative 2x plus y is greater than negative 4. So I'm going to start by isolating y. So I'm going to add 2x to both sides. I get y is greater than 2x minus 4. So let's see. What do I do now? Well, what I do is I have the boundary line. Y equals 2x minus 4. So the slope here is 2. Let me just put over 1. And the y-intercept is 0, negative 4. So 0, negative 4. So 0, negative 4 is right there. Slope being 2 over 1. Remember, this means that I go up 2 to the right 1. Up 2 to the right 1. Up 2 to the right 1. My line looks like this. And do I make it solid or dotted? Well, because this inequality is a strict inequality, we're going to use a dotted line. So it looks something like that. Sorry for the little curve at the bottom there. Finally, I decide whether to shade above or below. Because this is a greater than, I also shade above. This is 0, negative 4. This is 1, negative 2. This is 2, 0. Alright, let's try another one. This one, you'll see the subtlety, the little difference here. We're going to do negative 2x minus y is greater than or equal to negative 3. Again, first thing I'm going to do is I'm going to isolate y to put in slope-intercept form. So I start by adding 2x to both sides. I get negative y is greater than or equal to 2x minus 3. Now, be careful, I have a negative y there, so I'm going to divide by negative 1. But let's not forget the main rule for inequalities. When you multiply or divide by a negative, the inequality sign has to flip. negative 2x plus 3. So what is the boundary line? The boundary line is y equals negative 2x plus 3. Let's write down our information. Our slope is negative 2 over 1, and our y-intercept is 0, 3. Zero, 3 would be right here. And then I go down 2 to the right 1. Do I do a solid or dotted? Well, I'm going to look right over here. This means it's a solid line. And do I shade above or below? Well, because it's a less than or equal to here, I shade below. This is really, really important, by the way. Because if I had looked at this inequality up here, then I would have shaded above, and that would be completely wrong. You have to look at what the inequality says at the end when you're actually dealing with the slope-intercept form. Okay, let me do one more example. Oh, let me actually also label these points. This one was 0, 3. This one was 1, 1. And this one was 2, negative 1. We're going to do one last example. We're going to see the one case where something weird might happen. X is less than 1. Now, we cannot put this in slope-intercept form since the y is missing. So there is no slope-intercept form. That's okay because we can still do the problem. What's the boundary line going to be? The boundary line is still x equals 1. We need to remember how to graph x equals 1. X equals 1 is actually a vertical line. Here's x equals 1, and we're going to make it dotted because of this. Now, the one thing we have to worry about is which way do we shade? It doesn't make sense to say above or below because this is a vertical line. You can either shade to the right of it or to the left of it. So actually, when there are no y's and you just have x by itself, then it's simple. Less than tells you left, and greater than tells you right. So it just depends on which one it says. So in this case, because we have a less than, we use the left. That means I'm going to shade this way. And this is the point 1, 0 if we want to label something here. So you can always use the above or below method unless there are no y's. That's the only time that you have to worry about doing what I just did. Alright, thank you very much for watching. I hope this was helpful.